Let's examine some strategies for the data representation problems. You will be presented with graphs or tables of information related to some type of scientific information. I recommend the following two initial strategies for data representation problems. First, spend at least 30 seconds to a minute looking over the graphs and tables. Try to understand what is going on. Look for patterns. Second, don't get confused by complicated terms. Don't worry if you don't completely understand the information. The questions are based on reasoning and not on your previous courses. Answers to the questions can be found in the material. You should expect the following types of questions. Direct information. These questions test your ability to analyze scientific information. Drawing conclusions. These questions test your ability to interpret and reason with scientific material. Making inferences. These questions test your ability to generalize from the material and use your problem-solving skills to make predictions on what might happen if certain conditions are changed. Dr. Smith will now present and explain a data representation example.
In many bicycles, a series of front and rear gears are coupled. Each gear is composed of a number of teeth. The gears are used to increase or decrease the force generated by the bicycle, and as a consequence, to increase or decrease the resulting speed of the bicycle. The speed advantage, SA, of a bicycle, the number of times a machine multiplies the speed, is defined as SA equal number of front teeth divided by number of rear teeth. The mechanical advantage, MA, of a bicycle, the number of times a machine multiplies the force, is defined as MA equals number of rear teeth divided by number of front teeth. The following table shows the relationship between the number of teeth in the front gears, rear gears, and the resulting SA and MA. Let's apply our first strategy and look for patterns in the table. Scanning the first column, front gears, I notice a change between 50 and 40. At this point, I'm drawing a line. Now, looking at the top part of the table, scanning the rear gears column, I notice that the values increase. As these values increase, SA decreases and MA increases. Looking at the bottom part of the table, I notice the same relationship. As gears increase, SA decreases and MA increases. Now let's try a problem. Which gear combination produced the greatest mechanical advantage? To solve this problem, we need to look at the MA column, or the one related to mechanical advantage. We need to find the highest numerical value. Scanning the column, that seems to be 0.88. This corresponds to front gears of 40 and rear gears of 35. And I'm reading direct information off the table to come to answer D. Which of the following expresses the relationship between speed advantage and mechanical advantage? This question asks us to draw conclusions from this table of information. Looking at our notes, we notice that as SA decreases, MA increases, or vice versa. As SA increases, MA decreases. So the relationship between the two is inverse. Looking at our options, it seems that G is the one that expresses this relationship. SA increases and MA decreases. None of the others will work. So therefore, this is answer G. The smallest speed advantage in the table is produced by which of the following differences between the number of teeth in front gears and rear gears? This is a direct information question which involves two parts. First, let's find the smallest speed advantage, or SA. Looking at the table, this corresponds to a value of 1.14. This value of 1.14 is represented by front gears equal 40, rear gears equals 35. Finding the difference, we get 40 minus 35, which equals 5. Answer A. Front gears with 50 teeth and rear gears with 15 teeth would produce which of the following SA and MA? This is an inference question, asking us to make predictions with new values. Let's look at the top part of the table, the part corresponding to 50 teeth in the front gears. Then let's find 15 teeth for the rear gears in the second column. This would be between 10 and 20. Now this would correspond to an SA between 5 and 2.5 and an MA between 0.2 and 0.4. Let's look at our answers. The SA has to be between 5 and 2.5, which are options F and H. The MA has to be between 0.2 and 0.4. This narrows it down to option F, which is our answer. A speed advantage of 1.00 would be associated with which of the following mechanical advantages? This is also an inference question, asking us to make predictions with new values. There are at least two ways to solve this problem. First, let's use the table and try to infer what a mechanical advantage would be that corresponds to an SA of 1.00. Looking at the table, an SA of 1.25 corresponds to an MA of 0.80. As the SA decreases to 1.14, the MA increases to 0.88. Now, if the SA were to decrease to 1.00 or another 0.14 units, the MA would increase at least 0.08. At least. My best guess would be answer B here, that the MA equals 1.00, inferring it from the table. Another way to solve this problem would be to go back and look at the original definitions of SA and MA. SA equals number of front teeth divided by number of rear teeth. For SA to be 1, this implies that the number of front teeth equals the number of rear teeth. This means then that MA would also be equal to 1.00, since the number of rear teeth and the number of front teeth are equal. In this way, we also get to answer B.
Let's examine strategies for the research summaries. You should expect summaries of about 3 to 4 related experiments. Don't be distracted by unfamiliar words or complicated terminology. Try to figure out the main results of each experiment. Make a quick note beside each experiment of what's happening and how it relates to the hypothesis being tested. If tables are presented, look for patterns or relationships. As each new experiment is presented, make a quick note as to how this new experiment relates to the previous experiment. You should expect the following types of questions. Direct information. These questions test your ability to identify information for one or more experiments. Comparison of experiments. These questions measure how well you can compare the results of one experiment to the results of another experiment. Drawing conclusions. These questions ask you for the main results from one or more experiments. Making inferences. These questions test your ability to generalize from the material and to use your problem-solving skills to make predictions on what might happen if certain conditions are changed. Assumptions. These questions ask for the underlying assumptions used by the researchers in conducting the experiments. Dr. Smith will now present and explain a research summaries example.
A series of experiments was designed to determine to what extent different factors influence how pancreatic enzymes convert milk fat to fatty acids. Experiment 1. Enzyme and substrate milk concentrations were held constant. Temperature was varied, and the time required for fatty acids to be produced was measured in minutes. Experiment 2. The substrate, milk, amount was held constant and at 40 degrees centigrade, and the concentration of enzymes was varied. Experiment 3. The enzyme concentration was held constant and at 40 degrees centigrade, and the amount of substrate, milk, was varied. There's a lot of technical information in this research summary problem. To make our task easier, let's look for patterns in each experiment. In experiment 1, I noticed that as temperature increases, the time decreases at first and then increases. In experiment 2, I noticed as enzyme concentration increases, time decreases. In fact, it levels off at 5 minutes. In experiment 3, I noticed as substrate concentration increases, time also decreases, once again leveling off at 5 minutes for the last two values. Let's try a problem. Which of the following conditions would produce the shortest time to complete a reaction of converting milk fat to fatty acids? This is a direct information question. Let's look at the answers. An enzyme concentration of 0.10 from experiment 2 involves a time of 40 minutes. An enzyme concentration of 0.4 involves a time of 20 minutes. Moving to experiment 3, a substrate concentration of 2/5 involves a time of 15 minutes. And a substrate concentration of 7/0 involves 5 minutes. It looks like the shortest time to complete a reaction is answer D. From the conditions in experiment 1, a temperature of 35 degrees centigrade would produce a time to complete the reaction of approximately how many minutes? This is an inference question, asking us to make predictions with new values. Looking at the data in experiment 1, a temperature of 35 degrees centigrade would fall between 30 degrees centigrade and 40 degrees centigrade. This means it falls between a reaction time of 20 minutes and 5 minutes. Looking at the options, answer F is the only value between 20 minutes and 5 minutes. The answer is F. Which experiment or experiments can be used to indicate factors which influence the time it takes to convert milk fat to fatty acids? This question is asking us to draw conclusions about which factors influence time to completion. Looking at experiment 1, we know temperature influences time to completion. As temperature increases, time decreases and then increases. So experiment 1 is a factor. Looking at experiment 2, as enzyme concentration increases, time decreases. So enzyme concentration affects time. Let's keep experiment 2. Looking at experiment 3, as substrate concentration increases, time decreases. So this experiment is also important. Looking at our answers, we need all three experiments. Answer D. An enzyme concentration of 1.0 grams to 50 milliliters and a substrate concentration of 8 parts milk to 0 parts water would produce a time to complete a reaction of approximately how many minutes? This is an inference question, asking us to make predictions with new values. First, let's look at experiment 2. An enzyme concentration of 1.0 is associated with a time of 5 minutes. Looking at experiment 3, a substrate concentration of 8/0 is not in the table, but we could infer that the time would be 5 minutes, given that a substrate concentration of 7/0 is 5 minutes. Given we got 5 minutes from experiment 2 and 5 minutes from experiment 3, I would go with answer F in this problem. Which of the following is the best graphic representation of the data in experiment 3? This is a direct information question concerning experiment 3. Looking at our notes on experiment 3, we noticed as substrate concentration increases, the time at first decreases and then levels off at 5 minutes. So we want to pick a graph that expresses this relationship. Options A and B will out because they show a strict increase or decrease. Option D is also out because it shows an initial decrease and then an increase. Option C is our best graph here. It indicates an initial decrease and then a leveling off at 5 minutes. Answer C. In this series of experiments, the researcher is making which of the following assumptions concerning the conversion of milk fat to fatty acids? This is an assumption question. Assumptions involve factors which do not affect the outcomes of experiments and therefore need not be measured. Well, in this series of experiments, the researcher is measuring temperature, substrate concentration, and enzyme concentration, trying to determine the effect on reaction time. So options F, G, and H are out. This leaves only option J, which states that only the variables of temperature, enzyme concentration, and substrate concentration affect reaction time. This is what the researcher is assuming. Answer J.
Let's examine some strategies for the conflicting viewpoints problem set. Expect the summaries to conflict with each other and have different explanations for the same phenomenon. Don't get frustrated with the technical material. Look for the main points of disagreement or agreement between the writers. Reread each viewpoint depending on the question asked. You should expect the following types of questions. Direct information. These questions ask you to identify specific information about the viewpoint of Scientist 1 or Scientist 2. Comparison and contrast. These questions will ask you to compare the viewpoints of the two scientists. For example, in what ways are the two viewpoints similar to each other? In what ways are they different? Evidence questions. These questions ask you to identify additional evidence that supports or weakens the argument advanced by either Scientist 1 or Scientist 2. Dr. Smith will now present and explain a conflicting viewpoints example.
Two scientists present their viewpoints on the causes for the extinction of the dinosaurs. Scientist 1. Recent evidence indicates that the dinosaurs became extinct after the Earth collided with a huge comet or asteroid. The collision of this comet or asteroid with the Earth sent huge clouds of dust into the air. The dust remained suspended in the air for many months and lowered the surface temperature dramatically. The dinosaurs quickly froze to death. The discovery in 1990 of a buried crater, 112 miles in diameter, centered under a small town in the northern tip of Mexico's Yucatan Peninsula, supports this theory. The age of this crater is 65 million years old, the same time frame in which the dinosaurs became extinct. As additional evidence, an analysis of the KT boundary in the fossil record indicates a higher content of the rare element iridium than would be ordinarily found in the Earth's crust. Both comets and asteroids are rich in iridium. Scientist 2. Although the theory that the dinosaurs became extinct when the Earth collided with a huge asteroid is intriguing, the evidence supporting it has many problems. For instance, the crater found in Mexico is actually too small. An asteroid only a mile across, not big enough to affect the whole Earth, could have produced the crater. Additionally, dust particles sent into the atmosphere by collision would only have remained there a few days. Although comets and asteroids do contain a high content of iridium, the amount found in the KT boundary is very small, and could have been produced by numerous smaller collisions. Further evidence is needed before we can understand why the dinosaurs suddenly disappeared 65 million years ago. The dinosaurs became extinct approximately. This is a direct information question, and the answer can be found either by looking at Scientist 1 or Scientist 2. Let's look at this sentence. The age of this crater is 65 million years old, the same time frame in which the dinosaurs became extinct. From this sentence, we can answer this question. The answer is B, 65 million years ago. Which of the following pieces of evidence would support Scientist 1's position? This is an evidence question, asking us to support Scientist 1. Let's look at each option separately. Evidence of an asteroid collision 55 million years ago. Well, this wouldn't support Scientist 1. In fact, it's irrelevant. Scientist 1 claims the dinosaurs became extinct 65 million years ago. Amounts of iridium in other parts of the fossil record. This also is irrelevant. Scientist 1 is claiming that iridium in the KT boundary is the key factor. Research that dust particles can remain suspended in air for months. Well, this would help out Scientist 1. Scientist 1's position depends on the dust particles remaining there long enough so the dinosaurs froze to death. Let's check the last option. Evidence that the Earth's temperature didn't change dramatically. Well, this wouldn't support Scientist 1. Scientist 1's position depends on the temperature changing dramatically. Let's go with answer H. Which of the following pieces of evidence would weaken Scientist 2's position? This is an evidence question, this time asking us to weaken Scientist 2's position. Let's look at each option separately. An asteroid 10 miles across produced the Mexican crater. Would this weaken Scientist 2? Well, from this sentence, I think we could see it might. The crater found in Mexico is actually too small. An asteroid only a mile across, not big enough to affect the whole Earth, could have produced the crater. So if actually a bigger asteroid hit the Earth, Scientist 2 would be in trouble. Let's keep going. Dust particles from volcanoes remain in the atmosphere for 2 weeks. This wouldn't cause a problem for Scientist 2. Scientist 2 already believes that the dust wasn't in the air that long. Discovery of another crater in Mexico. Well, this is irrelevant. Evidence of other rare elements in asteroids. This too is irrelevant. The only thing we're concerned about is iridium. Let's go with answer A. Scientist 1 and Scientist 2 agree about which of the following? This is a comparison question, asking us to determine a point on which Scientist 1 and Scientist 2 agree. Let's look at each option separately. The amount of iridium in the KT boundary. Well, the two scientists disagree on this point. Scientist 1 indicates a higher content of iridium. Scientist 2, that iridium is very small. How long dust particles remain suspended in air? Well, we already know that they disagree on this point. How the dinosaurs became extinct? Well, that we know they disagree on this point because that's the purpose of the two passages. So finally, asteroids have collided with the Earth in the past. We know they agree on this point. Scientist 1, the Earth collided with a huge comet or asteroid, and Scientist 2, numerous smaller collisions, comets, and asteroids. Answer J. Both Scientist 1 and Scientist 2 would disagree with which of the following statements? This is also a comparison question, this time asking us to look for a point on which Scientist 1 and Scientist 2 disagree. Let's look at each option separately. Both comets and asteroids contain iridium. They don't disagree on this. They agree that both comets and asteroids contain iridium. They just disagree on the amount. Lowered surface temperatures caused the extinction of the dinosaurs. Well, scientist 1 agrees with this. Scientist 2 disagrees. Asteroids and comets have collided with the Earth. Well, both scientists agree with this point. So finally, the dinosaurs became extinct through gradual evolutionary changes. Both scientists disagree on this point. Let's look at the evidence. Scientist 1, the dinosaurs quickly froze to death. Scientist 2, why the dinosaurs suddenly disappeared 65 million years ago. So both of them would disagree with this statement. Answer D.